In this video, we're going to discuss applications of bearing. Bearing is an important idea in navigation. There are two different ways to express bearing. This first video, we'll talk about one of those ways, and in my next video, we'll talk about the other way for expressing bearing. So the first method is when a single angle is given, such as 164 degrees. It is understood that the bearing is measured in a clockwise direction from due north. So when you're given a single number like that and it's a bearing problem, you start with a due north line, and then you're going to rotate clockwise that many degrees. So something like this, 164 degrees. All right, so we have a ship that travels 50 kilometers on a bearing of 27 degrees, then travels on a bearing of 117 degrees for 140 kilometers. We want to find the distance traveled from the starting point to the ending point. We'll round our answer to the nearest hundredth. We'll start with a good diagram. They've given us a single number bearing, so we're starting with a due north line. And now we're going to rotate 27 degrees in a clockwise rotation and go 50 kilometers. So 27 degrees, 50 kilometers long. Well, now the boat is turning. And it's going to travel on a bearing of 117 degrees for 140 miles. Since it's turning, it's changing its bearing, we need to start with another due north line. And this time we're going to rotate 117 degrees clockwise from here. So if that's 90, that's about 117. And it traveled 140 kilometers. And then our question is to find the distance from the starting point to the ending point. So we're looking for this distance here. Okay. Well, I see a triangle. And I know two of the sides of the triangle. But I don't know what kind of triangle it is. Like, I could easily find side X using Pythagorean theorem if I knew it was a right triangle, but I don't know that it's a right triangle. So we want to what's called exploit the givens. We want to just see what other information we can get out of the information that we've been given. But that's kind of my idea. I see this triangle. If it was a right triangle, great, I could use Pythagorean theorem. We have these two due north lines, and I'm going to extend them. Because they're both due north lines, they're parallel lines. And if I look at this, this red line here, right, this is a transversal that's cutting those two parallel lines, and we know that alternate interior angles are congruent. So that means that this angle here, 27 degrees, is the same as that angle there. So we can get a portion of that angle across from the X. It's going to be 27 degrees. Too many clicks. I want that to be green. Okay. All right, well, it'd be great if we could get the rest of that angle, right? So we have this whole angle here. Because if one of them is going to be right, it looks like it's going to be that one. So again, looking at this due north line on the right, extending it, it's a straight line, and we know that straight lines have 180 degrees to them. So this is 180 degrees, and we can find this portion of it by subtracting 117 from 180. And if we do that, we get 63 degrees. Putting 27 degrees together with 63 degrees, I do indeed get a right angle. So I'm going to draw this breakout right triangle. And as discussed before, we can find x simply by using Pythagorean theorem. We don't even need trigonometry. So the x is going to be our hypotenuse because it's across from our right angle. And I'd probably just like put this whole thing, this whole square root, all in at once. We want to round to the nearest hundredth. We're going to get x to be equal to 148.66, and our unit is kilometers. Remember that the hypotenuse is the longest side of our right triangle, so it's no surprise here that we get our side x to be larger than 140. Let's try another. Two lighthouses are located on a north-south line. From Lighthouse A, the bearing of a ship 3,742 meters away is 129 degrees 43 minutes. From Lighthouse B, the bearing of the ship is 39 degrees 43 minutes. We want to find the distance between the lighthouses. We'll round our answer to the nearest hundredth. Like always, we're going to start with a good diagram. We've got two lighthouses located on a north-south line. So we're going to start with a north-south line. And I have two lighthouses, one here and one here. There is a boat that's out in the water here. From Lighthouse A, the bearing of this ship is 129 degrees 43 minutes. So when they give us a bearing like that, we always start due north, and then we're going to rotate that many degrees. So if this is 90, say that's 129 degrees 43 minutes. And that's a distance of 3,742. Then from Lighthouse B, the bearing of the ship is 39 degrees 43 minutes. Now, bearing is bearing, regardless of these two lighthouses being on a north-south line. If you're given a single number bearing, you're starting with a due north line and then rotating that many degrees. So don't start like south and then try to rotate. It's a bearing, so we always start due north, and then we'll rotate that many degrees. (39 degrees 43 minutes). And they did not give us this distance over here for the blue. but then they want us to find this distance in between. All right, well, I can see the triangle, but I don't know much about the triangle. I know one angle and I know one side. I need to know that it is a right triangle to be able to use Pythagorean theorem or any of our trig functions. So let's think about how we could prove that we had a right triangle here. So we've got this north-south line that makes, a straight line. So a straight line has a total of 180 degrees. So that means, looking here, this is 180 degrees, that I could find the portion inside my triangle by doing 180 degrees minus 129 degrees 43 minutes. So I'm going to do that, and that'll give us our angle on the inside. Subtracting, that's going to give us 59 degrees 17 minutes. We know that the sum of the interior angles of a triangle is always 180 degrees, so we could find the measure of our last angle here by simply doing 180 degrees minus these other two angles. Call that theta. And you see, when we do that, we're going to get 90 degrees. So we know now that this is a right triangle. I'm going to draw a breakout. Now we know this angle up top here, but honestly we don't need it. We needed it to prove that we had a 90, but we don't need it for the calculation. So from our bottom angle there, that 39 degrees 43 minutes, we have the opposite side and we're trying to find the hypotenuse. The trig function that's opposite and hypotenuse, that's going to be sine. So we get sine to be equal, sine of 39 degrees 43 minutes is equal to our opposite side over our hypotenuse. And now we solve for x. It's currently located in the denominator, so my number one priority is to get it out by multiplying both sides by x. Continuing to isolate x, we'll divide by that sine amount. We get x equals 3,742 divided by sine of 39 degrees 43 minutes. And then into our calculator it goes. We're rounding to the nearest hundredth. We get x to be equal to 5,856.10, and our unit is meters.